So this is Jacob's Algebra, Chapter 11, Lesson 2, Part 2, continuing on with algebraic fractions. So we finished number 6, which was just like number 13 that I assigned as homework. So next we're going to look at number 7. Number 7 is just like 14. It says, if possible, express each of the following fractions as an integer. So let's look first at Part B, which is 2x plus 8 over x plus 4. So the first thing that you always try to do with these is see if you can find a common factor anywhere. So in our numerator, we have 2x and we have 8. The greatest common factor there is going to be 2. So I'm going to factor out the 2. So 2 times what is 2x? That's got to be an x. 2 times what is 4? 2 times what is 8? That has to be a 4. So 2 times x gives us our 2x, 2 times 4 gives us our 8. And then our denominator is also x plus 4. So you can see our common term that appears in both the numerator and the denominator is x plus 4. So we can divide both the top and the bottom by x plus 4, replace both of those with 1, and we see that our answer is just 2. So the next one we're going to look at is Part E. Part E is 5x minus 3 divided by 3 minus 5x. Well, first thing I want to that I notice is that I've got a 5x in the top and the bottom, and I've got a 3 in the top and the bottom, but they're in a different order. So I'm just going to rearrange the order in the denominator. So we have 5x minus 3 in the numerator, and I'm going to write the denominator in the same order, negative 5x plus 3. All that I did was change the order that these terms were written in. I did not change what was actually there. Now I can look at the numerator and say, oh, well, this looks like it's just the opposite of what's in the denominator. So my denominator is negative 5x plus 3. I can rewrite our top as negative of negative 5x plus 3, because negative of negative 5x is positive 5x, and negative of positive 3 is going to be a negative 3. And now you can see negative 5x plus 3 is in the numerator, and negative 5x plus 3 is in the denominator. So I can divide both sides, I'm sorry, not both sides, but the top and the bottom, by negative 5x plus 3. And what I get is a negative 1, because I have this negative here that was outside of the parentheses. Okay, so now let's look at part F from number 7. And part F is 3 plus 5x over 3 minus 5x. Now this one is different. Notice we do still have our terms in the same order. We have a 3 and then we have a 5x. But in the numerator I'm adding, and in the denominator I'm subtracting. Neither the numerator nor the denominator can be factored. So there's actually nothing else I can do. This one I can't do anything to at all. So I write not possible. It is not possible to write this fraction as an integer. So that was number 7, which is just like number 14. Let's look now at number 8. Number 8 says, what should replace the blank in each of the following equations to make it true for all allowable values of x? This means we're going to say if our value of x would make the denominator 0, then we're going to ignore that one. We're not going to use that value for x. Okay, so let's look at part A first. We have 7 over x is equal to 21 over something. We need to know what goes down here on the bottom. Well, look at our numerator. What do we have to do to 7 to get 21? Well, we have to multiply by 3. 7 times 3 is 21. So we need to do the same thing to the denominator. X times 3 is 3x. So 3x is what goes in the blank spot. Okay, let's look at part C. We have 3 over x plus 3 is equal to 6 over blank. Okay, so what do we have to do to the numerator to get from 3 to 6? We had to multiply by 2. So that means we should do the same thing to our denominator. 2 times x is going to be 2x. 2 times 3 is going to be 6. So we have 6 over 2x plus 6. Okay, the next one we're going to look at is part E. Part E is x minus 1 over x plus 8. I'm sorry, not a plus. X minus 1 over x minus 8 is equal to 4x minus 4 over something. Okay, well, looking at the 4x minus 4, what I notice is that that actually can be written as 4 times the quantity x minus 1, because 4 times x is 4x. 4 times negative 1 is negative 4. So it looks like what I did to get from x minus 1 to 4x minus 4 was to multiply by 4. So that must be what I do in the denominator as well. I'm going to multiply by 4. X times 4 is 4x. Negative 8 times 4 is negative 32. So 4x minus 32 is what goes in our blank spot. Okay, so I'm going to get a new page, and we're going to do one more part from number 8, which is part F. We have 1 over x minus 5, that's supposed to be a minus, equals blank over x squared minus 25. Okay, so what do I notice here? I notice that my first term is the square of this term, and my second term is the square of this term, and I'm subtracting them. So I have a difference of two squares. I have x squared minus 5 squared. And how would I get that? In order to get the difference of two squares, I must have x plus 5 times x minus 5. Well, I started off with x minus 5, so that means I must be multiplying it by x plus 5. That has to be what I have, that's supposed to be a times. That has to be what I multiplied x minus 5 by. So that means we need to multiply our numerator by x plus 5. So we just put x plus 5 up here because we already had just a 1 on the top. So x plus 5 is what goes in the blank. So that was number 8, which is just like number 15 that I assigned as homework. Let's look now at number 9. Number 9 says, if possible, reduce the following fractions. So you might not be able to reduce the fraction that you're given. Let's look first at part C. We have 8x over 2x minus 4. So first thing I can see is that I can, there's a common factor in the denominator. So I can write my numerator again, 8x, and my denominator I can factor out a 2. 2 times x will give us 2x. 2 times negative 2 will give us negative 4. And now I see my numerator has an 8, my denominator has a 2. Those have the common factor of 2, so I can divide both of those by 2. 8 divided by 2 is going to give me 4. 2 divided by 2 is going to give me 1. And so I end up in the numerator, 4 times x is 4x. In the denominator, 1 times x minus 2 is just x minus 2. So 4x divided by x minus 2 is going to be our simplified fraction. Okay, let's look at part F. Part F is x minus 4 divided by 3x minus 12. And look at this, I see in the denominator that 3 is a common term in both, 3 is a common factor in both terms. So I'm going to copy my numerator, and in the bottom I'm going to factor out my 3. And I can see that 3 times x will give us my 3x. 3 times a negative 4 will give us our negative 12. Numerator and denominator both have x minus 4, so I can divide the numerator by x minus 4 to get 1, denominator by x minus 4 to get 1, and so I end up with 1/3. And then let's look at part I. We have x cubed plus x squared over x plus x squared. So in my numerator, I can see that x squared is a common term. So I can write x squared times x, because x squared times x is x cubed, plus 1, because x squared times 1 is x squared. And then in the denominator, x is a common term. And x times 1 will give us x. X times x will give us x squared. Okay, now let's look at the fraction that we have. Well, we have x squared in the numerator, we have x in the denominator. I can divide both of those by x. X squared divided by x will leave us with x. X divided by x will leave us with a 1. And then here I have an x plus 1 in the numerator and a 1 plus x in the denominator. It doesn't matter what order we write those in. X plus 1 is the same as 1 plus x. Since that appears in both the numerator and the denominator, I can divide them. So x plus 1 divided by 1 plus x is 1, and 1 plus x divided by 1 plus x is 1. So what we have here is actually just x. Let's do a couple more parts. Let's look at 9j. That is 3x plus 6 over 2x plus x squared. My numerator, the common term is 3, and I would factor that as 3 times x plus 2. 3 times x is 3x. 3 times 2 is 6. Denominator, I have a common term of x. X times 2 is 2x. X times x will give us x squared. And notice we have an x plus 2 in the numerator and a 2 plus x in the denominator. Those are equal because in addition, it doesn't matter what order the terms are in. So we can divide both the numerator and the denominator by x plus 2 and get 1 in place of each of those. And so our fraction is just 3 over x. Now let's do just a couple more examples from number 9. Part K, we have x plus 4 over x squared minus 16. Okay, in the denominator, you can see we have x squared minus 16. That is a difference of 2 squares. This is x squared minus 4 squared. And so that means that we can factor our denominator. I'm going to write my numerator again, x plus 4. My denominator, with the difference of 2 squares, I write the first term plus the second term times the first term minus the second term. So now we can see we have x plus 4 in the numerator and in the denominator, so we can divide both of those by x plus 4. X plus 4 divided by x plus 4 is going to be 1. And so we end up with 1 over x minus 4. The last part we're going to do from number 9 is part L, and that is 5x minus 25 divided by x squared minus 10x x plus 25. Okay, so in my numerator, it's easy to see that I have a common term of 5, so I can factor that out, 5 times x minus 5. My denominator is also factorable. Notice that we have our first and last terms are squared. This is x squared, and this is 5 squared. And our middle term is the double of the first term times our last term. So what we have down at the bottom is x minus 5 squared. Or I'm actually just going to write it out twice. X minus 5 times x minus 5. So we can divide both the top and the bottom by x minus 5. And what we will get as our final answer is 5 divided by x minus 5. So that was number 9, which is just like number 16 that I assigned as homework. The last one that we're going to do here is number 10. Number 10 is just like number 17 that was assigned as homework. So you're going to be given 2 expressions. On the left, we have x squared plus 3x minus 10 over 5x minus 10. And on the right, we have x plus 5 divided by 5. And we're going to try several different values of x and see what happens. So if x equals 0, what do we get with this first expression? Well, we have 0 squared is 0, plus 3 times 0 is 0, minus 10, that's supposed to be a 10, divided by 5 times 0, which is 0, and then minus 10. So we have negative 10 over negative 10, that's just a 1. When we plug in 0 to the expression on the right, we have 0 plus 5 divided by 5. That will give us, 5 over 5, which is just 1. Okay, let's try another value for x. We'll use 3. 3 squared is 9. 3 times 3 is also 9. And then we subtract our 10. We're going to divide that by 5 times 3 is 15. And then subtract our 10. So in the numerator, we have 9 plus 9 is 18. Minus 10 is 8. In the denominator, we have 15 minus 10, which is 5. Now we plug it into our other formula. X plus 5, that's 3 plus 5, divided by 5 is 8/5. So if you look closely at these 2 expressions, you should see that the second expression is just the first expression simplified. So you should get the same answer both ways. If you don't get the same answer both ways, then you have done something wrong. This was number 10, which is just like number 17 that I assigned as homework.